Dear students, in the previous classes you solved some problems based on Coulomb's force between 2-point charges. So in this class we shall take up some problems on the concept of electric field. So here is a problem. 2-point charges plus 0.2 microcoulomb and plus 0.8 microcoulomb are placed at a distance of 0.15 meter apart. Here there are 2-point charges. The first one is plus 0.2 microcoulomb and the second one is plus 0.8 microcoulomb. These two are separated by 0.15 meter. Now the question is, at what point on the line joining them the electric field is zero? You are asked to find the distance of the point where the electric field due to these two charges can become zero on the line joining the two charges. So this is the line joining the two charges. So on this line you are asked to find the point where the electric field is zero. So here first you represent the direction of electric field at a given point. Say if I take a point somewhere here, due to this positive charge electric field is in this direction, due to this positive charge also electric field is in the same direction, therefore the electric field will add up and hence anywhere this side electric field cannot become zero, because I told you earlier that due to a positive charge electric field is directed away from the charge. Due to a negative charge at any given point electric field is directed towards the charge. So these two charges being positive charges, due to both charges at any point this side electric field is in this direction, so nowhere this side electric field can become zero. Similarly, if I consider the point this side of this 0.2 microcoulomb charge, due to same reason, that means due to this positive charge electric field is in this direction, due to this positive charge also electric field is in the same direction, therefore anywhere this side electric field can not become zero. If I consider some point here, say this point is A, this point is B, this point is C. At this point C, due to this positive charge electric field is in this direction. That is electric field at C due to the charge at A, it is in this direction. Due to this positive charge at this point electric field is in this direction. It is away from the charge. So this is ECB. That means you consider this distance to be x. The remaining distance will become 0.15 minus x. So for the electric field at C to be 0, the magnitudes of these two fields must be equal and the directions must be opposite. So let x be a point distant x from 0.2 microcoulomb where electric field is 0. That means at C, electric field at C due to the charge at A, this should be equal and opposite to electric field at C due to the charge at B. Therefore, the magnitudes of these two charges should be equal. ECA should become equal to ECB. The formula for electric field at a point due to a point charge, it is given by 1 by 4 pi epsilon naught charge at A divided by the distance AC square 1 by 4 pi epsilon naught charge at B divided by the distance CB square. So these common terms you can strike off. This QA, this is 0.2 microcoulomb, this is X, and this is 0.8 microcoulomb, and this is 0.15 minus X whole square. So these terms will cancel. Now you simplify and you find the value of X. So 0.2 divided by 0.8, it is equal to X square divided by 0.2 divided by 0.8 is equal to X square divided by this one. On simplification, this becomes a 2 by 8, which means 1 by 4. So this will be X divided by 0.15 minus X whole square. So if I find the root, 1 by 2 is equal to X divided by 0.15 minus X. On cross multiplying and finding the value of X, it comes to nearly 0.05 meter. So like this, whenever you are asked to find the point where the electric field is 0, or sometimes the same thing can also be called as null point. Whenever you are asked to find the null point, first you have to find out where the field can become 0. Sometimes one may be positive charge, another may be negative charge. So in that case, there will be different points where the field can become 0. So you have to identify where the field can become 0, and by putting this condition you can find out the distance from any one of these two charges. That means at 0.05 meter from 0.2 microcoulomb or 0.1 meter from 0.8 microcoulomb. So these type of problems you can expect particularly in competitive examinations, or in part B or part C in the annual examination. Now I will take one more problem. A pair of pith balls suspended in air from the same point by strings of 10 cm long. If they repel each other to a separation of 8 cm, what must be the charge on each? So the given problem is like this. Here there are two pith balls separated by a distance of 8 cm. There are two charged pith balls. When both of them are suspended from the same point by two strings of length of 10 cm each, they get separated by a distance of 8 cm. So if that is the case, you are asked to find the charge on each pith ball. So mass of pith ball is given. Mass of pith ball, this is given as 1 gram, and this acceleration due to gravity 10 meter per second square. See, pith ball means there are light spheres which can hold some charge. So they are called pith balls. Light sphere, generally they are made of plastic or polystyrene. So they are lightly charged. When these two pith balls are suspended from the same point by two strings of length 10 cm each, because of the charge on them, they repel each other by a distance of 8 cm. So this is the data given. From this you are asked to find the charge on each pith ball. So first we shall assume that let Q be charge on each pith ball. So first you find out what are the various forces acting on each pith ball. See here, this is the midpoint. So this distance is, say this is A, this is B, at this point BC. So this AC or CB becomes equal to 4 cm. If I consider the various forces acting on each pith ball, because of the electrostatic force of repulsion between these two charged pith balls, they tend to move this side. So this is the direction of force. And each is having a mass of 1 gram. So there is a gravitational force acting like this, which is equal to weight given by mg. And also there will be a tension T acting on the string. Now, if I consider this angle to be theta, if theta is the angle made by each string with respect to the vertical, then this angle also become equal to theta. They are opposite angles. Now this tension T, it has got two components. This side it is a T cos theta and this side it is T sin theta. So under the influence of these three forces, the system is in equilibrium. So at equilibrium, all the forces must be balanced. That means this T cos theta should become equal to W and this T sin theta should become equal to F. From this condition, you can find out this charge. So here, the system is in equilibrium due to W, F and T. Therefore, this T cos theta, this one, T cos theta, this must be equal to W. This T sin theta, it must be equal to F. Therefore, if I divide these two equations, tan theta is equal to F divided by W. Therefore, this F is equal to W tan theta. So it is mg. What is this tan theta? So this BC divided by OC. So this is the opposite side, this is the adjacent side. So BC by OC gives tan theta. And further, this force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This gives the force. So this is equal to mg BC, which is this distance BC, it is 4 centimeter. That is 0.04. And what about this one? OC, root of 0.1 square minus 0.04 square. So this is 9 into 10 to the power of 9 into q square divided by 0.08 square. This distance is 8 centimeter. So this is equal to, this m is 1 gram. That means 1 into 10 to the power of minus 3 kg. This g is 10 meter per second square. And this is 4 into 10 to the power of minus 2 divided by this one. How much you get? So 0.01 minus 0.16. So it is root of 0.01 minus 0.0016. So it is 0.0084. Now on simplification you find the value of this charge Q it comes to be nearly 56 nanocoulomb. So this is the idea in solving this type of problems. Here there are two charged pith balls. Because of repulsion, they tend to get separated by 8 cm. Under these three forces, system is in equilibrium. So under equilibrium condition, this becomes the force. From that force, we can find the charge. In the next problem, you can do it by yourself. There are 2 point charges. Plus 2 nanocoulomb, minus 8 nanocoulomb. They are separated by 0.1 meter. Find the position of null point and the line joining the two charges. So as I already told you, null point means it is the point where the resultant electric field can become 0. So this is the line joining the two charges. First you make out where you can get the null point. If I consider some point here, in between the line joining the two charges, if I consider some point here, due to this positive charge, electric field is in this direction. Due to the negative charge also, electric field is in this direction. That means the field adds up. So nowhere in between the line joining the two charges AB, the field can become 0. Nowhere between A and B, the field can become 0 because the field due to each charge gets added up with the other. Similarly, if I consider some point here, due to this negative charge, electric field is towards the charge. Due to the positive charge, electric field is away from the charge. Here, this E, it is proportional to Q divided by R square. More is the charge, smaller the distance, larger will be the electric field. Here see, compared to this charge is more, distance is smaller. That means at all points on this side, field due to this charge, it is more than the field due to the other charge. So at every point along this line, field due to this negative charge, it will be more than the field due to the positive charge. Therefore, nowhere this side the field can cancel. Therefore, you can't get null point this side. It's not possible. So null point is not possible here. Null point is also not possible here. If I consider some point here, say C, due to this positive charge, the field is in this direction. Due to this negative charge, the field is in this direction. So this is E, CA. This is E, CB. So you take this distance as x. This distance will become x plus 0.1. So for null point, what should be the condition? This ECA should become equal to minus of ECB. That means these two fields must have equal magnitude but opposite in direction. Therefore ECA, it is equal to ECB. Now 1 by 4 pi epsilon naught QA divided by AC square, it is equal to 1 by 4 pi epsilon naught QB divided by CB square. Now you substitute all these values and you find the value of x. It comes to be nearly 0.1 meter. That means at a distance of 0.1 meter from A, the resultant electric field can become 0. So two charges are given like this. you are asked to find the position of null point. So this null point comes to be 0.1 meter on the line joining the two charges. That means here, not in between the two charges. So you get null point here. In the next problem, it is given that there is a pendulum bob of mass 0.1 gram. It is carrying a charge of plus nanocoulomb, 10 nanocoulomb. It is in rest in a horizontal uniform electric field of 2 × 10 to the power of 4 Newton per coulomb. Find the angle it makes with the vertical and the tension in the string. You are asked to find this theta and also this t. The given problem is like this. Here there is a pendulum which is suspended like this. Now here there is a uniform electric field like this. There is a uniform electric field. See, this pendulum bob being having this much of charge suspended vertically, because of this electric field, it experiences force and it tends to move like this. This being a charged body, when a charged body is in the electric field, the charge on it being positive, it experiences force along the direction of electric field. So this is the force on the charged body. And it has mass, therefore there is a weight W will be acting like this and there will be a corresponding tension T. Now the question here is, you are asked to find this angle theta and this tension T. So when this angle is theta, obviously this angle is also become theta. As you have seen in the previous problem, at equilibrium, all the forces must be balanced. So the component of T along this side, T cos theta, this becomes equal to W. Similarly, the component of T along this side, this is T sin theta, so it must be equal to F. If I divide these two equations, it becomes a tan theta. This tan theta is equal to F divided by W. What is this F? When a charge Q is in the electric field E, this force F will become Q into E. So, earlier there were two pith balls, charged pith balls. The force between them is given by Coulomb's law. But in this particular problem, this charged pendulum, it being in the electric field, it experiences force this side. The magnitude of this force is given by Q into E. So tan theta is equal to QE by mg. You take all these values here in this formula, and from that you find your tan theta. This QE is given as 10 nanocoulomb. This E is 2 into 10 to the power of 4. This m is 0.1 gram, 0.1 in 10 to the power of minus 3 kg, and this acceleration due to gravity, you take g, 10 meter per second square. Now you calculate this tan theta, and from that you find theta. See, you must be very careful regarding this substitution. This mass is given in gram. So while doing substitution, you have to take it in kg like this. If you forget about these conversions, ultimately you will end up with wrong answer. So you take care of these units particularly. So you find this theta in this problem, it comes to be nearly 11.5 degree. You do this calculation and if you find the theta, you get nearly 11.5 degree. Once you get this theta, you substitute either in this equation or in this equation. From that you calculate this t. So t is equal to w by cos theta or f divided by sin theta. So this f is QE divided by sin 11.5 degree. If you do that calculation, it comes to be nearly 1 into 10 to the power of minus 3 Newton. You will get that much. So, when two charged spheres are given under equilibrium, this F is given by Coulomb's law. When a charged sphere is kept in the uniform electric field, it experiences a force. That force is given by QE, and rest of the procedure is same. So by following this procedure, you can find out the unknown thing easily. You look at this next simple problem. There is a sphere of radius 0.5 meter, 0.05 meter. How many electrons must be removed so that it acquires a charge of 4 in 10 to the power of minus 15 coulomb? So here, number of electrons to be removed so that this Q is equal to 4 in 10 to the power of minus 15 coulomb. So, if this sphere of radius this much is to acquire this much of positive charge, how many electrons are to be removed? So obviously you have to use the concept of quantization of charge. Since Q is equal to NE, this 4 into 10 to the power of minus 15 is equal to N into 1.6 into 10 to the power of minus 19. So you find this N, it comes to be nearly 2.5 into 10 to the power of 14 electrons. So this is the one part of the problem. The second part is, what is the electric field at a point on the surface of the sphere? Electric field on the surface of the sphere. So here you are asked to find this electric field. So it is 1 by 4 pi epsilon naught q by r square, or otherwise sigma divided by epsilon naught. So q is known, r is known. So you do this substitution and calculation. It comes to be 0.014 Newton per coulomb. So this is the second part of the problem. The third thing is, at 0.04 meter from center, what is this electric field? So this is the problem. See, radius is given as 0.05. This distance is given as 0.04. Since the given point is less than radius, the point lies inside the sphere. You know that inside the sphere electric field is 0. Since r is less than r, this E is equal to 0. See, this problem is given here just to recollect these various formula, that is sigma is equal to q divided by a, q by a, that means q divided by 4 pi r square. And also, while studying Gauss law, you learned that in case of a charged sphere, though the charge resides on the outer surface of the conductor, it acts like a point charge at the center. That is how you got this formula. The formula for field on the surface and field at a distance r from a point charge is same. Next, inside the charged sphere, electric field is 0. That is how E becomes 0 here. Next one. So these type of problems were asked many times in annual examination. Here there is a square. PQRS. Of side 0.05 meter. Charges of plus 10 microcoulomb, minus 20 microcoulomb, plus 20 microcoulomb, minus 10 microcoulomb are placed at the corners P, Q, R and S respectively. So P, Q, R, S is like this, and at these four corners these charges are there. So you have to represent these charges correctly, otherwise you won't get the correct answer. Now the question is, find the magnitude and direction of electric field at the center of the square. So center of the square means it is the point where the diagonals intersect. So you join these diagonals like this. So this becomes the center of the square. You are asked to find the electric field at the center, both magnitude as well as direction. First you represent the direction of electric field at O due to each charge. Due to this positive charge at this point, electric field is in this direction. This being a positive charge, electric field at a point is away from the charge. So this is EOP. Next, due to this negative charge, electric field at this point is towards the charge. So this is EOQ. Next, due to this positive charge, electric field is away from the charge. This is EOR. Due to this negative charge, electric field is towards the charge. So EOS. So due to this positive charge, it is away at this point. Due to this negative charge, it is towards the charge at this point. Due to this positive charge at this point, electric field is in this direction. Due to this negative charge at this point, electric field is in this direction. Charge being negative. Next, at O, these two fields are in opposite direction, so you find their resultant. These two fields are also in opposite direction, you find their resultant. Next, 4 electric fields are reduced to 2. By applying parallelogram law, you find the resultant electric field at O. That is the procedure. To calculate the magnitudes of these electric fields, you should know this distance. So in the previous class, I told you that in any square, the length of the diagonal PR, it is root 2 times the side, that is PQ. Length of this diagonal is root 2 times side. So therefore, this OP, OQ, OR, OS, this becomes equal to diagonal divided by 2. That means root 2 into 0.05 divided by 2. This 2 can be written as root 2 into root 2. So one root 2 will cancel. So you will be left with 0.05 divided by root 2 meter. So you just remember that in any square, length of the diagonal is root 2 times the side. Half the length of the diagonal is 1 by root 2 times the side. So if you remember that much, you need not do this calculation again and again. Now, electric intensity or electric field at O due to charge at P. EOP, first you write the formula. 1 by 4 pi epsilon r charge at P divided by this distance OP square. First you write the formula once, and now you do this substitution. 9 into 10 to the power of 9, 10 into 10 to the power of minus 6 divided by this distance OP is 0.05 divided by root 2 whole square. So this will become 9 into 10 to the power of 4 into 2 divided by 25 in 10 to the power of minus 4. So this is 18 divided by 25 into 10 to the power of 8. So this is 18 by 25 into 10 to the power of 8 Newton per coulomb along AO in this direction, sorry, PO. You can write it as along PO or along OR, both are one and the same. So this is EOP. Similarly, EOQ, this one. Here this distance is equal, but the charge is double. Therefore, this will become double. 36 divided by 25 into 10 to the power of 8 Newton per coulomb along OQ. EOR, this one. This distance is same, magnitude of charge is also same. So this is 36 divided by 25 Newton per coulomb along RO, this direction. And EOS, this is again this distance is equal, this charge is equal, so magnitude of electric field will be same. So it is 18 divided by 25 into 10 to the power of 8 Newton per coulomb along OS. So I calculated one field, by approximation I found the other fields. Just by estimation I found the other fields. Next here I will find the resultant of this EOP and EOR as EOP and EOR being opposite, as these two fields are opposite. They result in E1. See, out of these two, which is stronger? EOP and EOR. This EOR is stronger, therefore the resultant is EOR minus EOP. So it is 36 by 25 minus 18 by 25 into 10 to the power of 8 So if I do this calculation, it will be 18 by 25 into 10 to the power of 8 Newton per Coulomb. In which direction? Along this side. So this is the direction of E1 along RO, this side. See, this field EOR, it is stronger than this field EOP. The resultant of these two is E1, which is in this direction. Similarly, this EOS, EOQ, EOQ and EOS being opposite, they result in E2. So among these two, which is stronger? This EOQ, it is stronger than EOS. EOQ, EOS, this is stronger, so it is EOQ minus EOS, that is 36 by 25 minus 18 by 25 in 10 to the power of 8. So this is 18 by 25 in 10 to the power of 8 Newton per Coulomb along. This being stronger, it is in this direction. This is E2. That is along OQ. Now, 4 electric fields, they have been reduced to 2, E1 and E2. Therefore, resultant electric field at O, EO, so it is root of E1 square plus E2 square plus 2 E1 E2 cos 90, which is 0. Since E1 is equal to E2, this one, E1 is equal to E2, this becomes root 2 times E1 or E2, that means root 2 into 18 divided by 25 into 10 to the power of 8. So you do this calculation. If you do that calculation, roughly you will get 1.02 into 10 to the power of 8 Newton per Coulomb. If you do this calculation, you will get nearly 1.02 into 10 to the power of 8 Newton per Coulomb. What about its direction? E1 and E2, they being equal in magnitude. Here see, this one and this one, they being equal in magnitude. The resultant must be making equal angle with both, like this. That means the electric field will be along SP or RQ. So, this is the magnitude of resultant electric field at this point, and its direction is along SP, that is parallel to SP like this, or along RQ. You just remember the procedure how we found the electric field at the center of the square. So by following this procedure, you can solve all problems related with the charges being kept at the corners of a square. A similar type of problem was asked in the annual examination once, like 4 charges. You do this problem as homework now. plus Q plus 2Q plus 3Q plus 4Q. They are kept at the corners A, B, C, D of a square of side point 1 meter. So, here at O, electric field at O is given as 5.1 in 10 to the power of 3 Newton per coulomb. Electric field at the center is given as 5.1 in 10 to the power of plus 3 Newton per coulomb. You are asked to find this Q. So this is the problem. So as you did here, first you represent the directions of electric field. This is K, this is Q, and you know the distance. By following the same procedure, you find E naught. This E naught comes to be this much, so from that you find the value of Q. See, in the previous problem, these charges were given and you are asked to find the field at the O. But in this problem, these charges are not given. Simply it is mentioned that plus Q, 2Q, 3Q, 4Q like that. Electric field is given at the center. From this you are asked to find Q. You have to follow the same procedure. You keep this charge as Q and you find this distance and you write this expression in terms of K and Q. You write this expression in terms of K and Q. Similarly, these other 4 expressions also. Finally, you arrive at this formula and you substitute for this E naught, and from that you get the value of this Q. You try this problem by yourself. So we shall continue in the next class.